Dear students, this is Rao sir from Sri Balaji Educare Center, and I am the physics faculty member and the director of this institute. Okay, so today I want to explain the basic concepts of gravitation, my dear students. From this gravitation, you will get minimum 2 to 3 questions in the NEET exam, my dear students. Minimum 2, maximum 3. So gravitation is one of the very easiest chapter in the physics. So let me start with that. Let me explain few concepts, and after that we solve even few problems also. I hope that you enjoy this session. So you know the acceleration due to gravity, my dear students. Acceleration due to gravity is denoted with the letter small g. So acceleration due to gravity is what? So when an object is falls from a certain height, it is attracted towards the center of the earth. The gravitational pull towards the center of the earth creates the acceleration in the body. When there is a force on a body, then there will be a certain acceleration. The acceleration produced in the body towards the center of the earth is called acceleration due to gravity, and it is denoted with the letter small g. And you know the relation between small g and capital G. Small g and capital G relation is G is equal to G capital M by R square. This is one of the very important expression, my dear students. How you got it? Just within 1 minute you can learn it. Let us consider the earth of mass capital M and radius capital R. An object of mass small m is placed over the surface of the earth. Then the forces acting on the object are, one is gravitational pull is acts towards the gravitational force on this body is acts towards it, because the body will try to attract the earth. Gravitational force on the body is acts towards it, and weight is acts downwards. The weight of the body is acts always towards the center of the earth, and gravitational force, you know that it is a pure attractive force. Gravitational force is a pure attractive force. The gravitational forces acts upwards. In this direction, gravitational forces acts. In this direction, towards the center of the earth, weight is acts. In equilibrium position, gravitational force and weight are equal. Gravitational force between the two objects, G, M1, M2 by distance square, and this is mg. M and M is cancelled, so finally you are getting small g is equal to capital G capital M by R square. Here capital G, you know that it is called universal. You know its value. The value of universal gravitational constant is 6.67 into 10 power minus 11 Newton meter square kg power of minus 2. You know this value, my dear students. So many times in exams, the question is given, what is the unit of capital G? What is the dimensional formula of capital G? Which is also very, very important, my dear students. Okay. So acceleration due to gravity on any planet is depends on the mass of that planet and the radius of that planet. It do not depends on capital G. Capital G is a universal gravitational constant. It is a constant. The m is not mass of the object. M is the mass of the planet. Mean acceleration due to gravity is directly proportional to mass of the planet and inversely proportional to square of the distance from the center of the planet to the body. So this is a very, very important expression, my dear students. Basing over this concept also, many times in competitive exams, problems are given. Now, let me discuss few problems with you now. Please, all of you note down. The acceleration due to gravity on the earth is, on the surface of the earth is, the acceleration due to gravity on the surface of the earth is G. What is the gravity on a planet having double the mass and of the radius of the earth? This is our question, my dear students. The acceleration due to gravity on the surface of the earth is small g. What is the acceleration due to gravity on a planet whose mass is double that of the earth and whose radius is half that of the earth? Now we solve this problem. You know the relation between capital G and small g. G is equal to G capital M by R square. This is a constant. Gravity is directly proportional to mass of the planet and inversely proportional to square of the distance. Using this relation, you can write gravity on the planet to the gravity on the earth is equal to gravity on the planet to the gravity on the earth is equal to mass of the planet by mass of the earth, radius of the earth by radius of the planet, because they are inversely proportional. Square लेना है इसका. वैसे लिए तो mass of the earth, if you take it as m, mass of the planet is given as 2m. Gravity on the earth is given g. This is gp. It is. Radius of the earth is r. Radius of the planet is r by 2. It is given. So here m and m is cancelled, r and r is cancelled. This 2 will move up. So what you are getting finally, if you calculate it, so finally you will get gp by g is equal to 1 2 you are getting, and here 2 square you will get. 2 square means 4 to the 8. Therefore gp is equal to 8g, means on that planet the gravity is 8 times that of on the surface of the earth. Please note down, my dear students. Next, now let me explain one more problem to you. So before going to that problem, so you should know some theory part, my dear students. So just now you have taken that gravity on the surface of the earth, I can write it as G is equal to Gm by R square. I can write. What is H is equal to Gm by this? I can write it as R plus H whole square. I can write, my dear students. If you take this is equation 1 and this as equation 2, and equation 2 by equation 1, if you do that, this Gm is cancelled, then you will get R GH by G is equal to R by R plus H whole square मिलेगा आपको. Therefore, you are getting GH is equal to G into R by R plus H whole square. So this is the relation between gravity at certain height from the surface of the earth and gravity on the surface of the earth, my dear students. Now we solve the problems based over this, my dear students. It's a very important one. You will get a question like this. This is today's second question. So the gravity on the surface of the earth is, the gravity on the surface of the earth is small g. What is the gravity at a height capital R from the surface of the earth? This is our question. The gravity on the surface of the earth is G. What is the gravity at a height capital R from the surface of the earth? Here H is height from the surface of the earth, my dear students. You know this formula. You know gravity on the earth. You know radius of the earth. You know even height of the body from the surface of the earth also you know. Therefore, you substitute all the values in this equation. This is R by R plus R, because since here H is equal to R, so whole square you are getting. This is equal to, if you solve it, gravity at certain height is equal to G into R by R plus R is 2R, whole square it is. GH is equal to G into RR is cancelled, 1 by 2 whole square. You will get it as 1 by 4, you will get this. So therefore, finally you are getting GH is equal to G by 4 you will get, my dear students. Mean the acceleration due to gravity at a height equal to the surface of radius of the earth is equal to G by 4, my dear students. Such type of questions given many times in the NEET exam, my dear students. Many times it is given. He may ask, what is the acceleration due to gravity at a height which is equal to 10 times that of the radius of the earth? Like that he may ask. You can solve all such questions using this expression, my dear students. So this is one of the very important question, my dear students. And in this only, you will get, on this model only, you will get some other problems also. But you try to remember that relation between GH and G. You know that GH is equal to small g into R by R plus H whole square. You need to remember it, my dear students. Continue. You need to remember it is very important, my dear students. Now, another question is, this is today's third question, my dear students. The question is, at what height from the surface of the earth the acceleration due to gravity becomes 64% that of on the surface of the earth? This is my question, my dear students. At what height from the surface of the earth the acceleration due to gravity becomes 64% that of on the surface of the earth? Mean gravity on the earth is G. Gravity at some height is 64% of this. 64% means that 64 by 100. 5% means that 5 by 100. So you can write GH is equal to G into R by R plus H whole square. Here GH is given 64% of the gravity on the earth. Here also G. This is R by R plus H whole square. This G and G is cancelled. I want to get H. So here square is there. Take square root to both the sides. Root of 64 by 100 you are getting as R by R plus H you are getting. Root 64 mean you will get it as 8. Root 100 mean 10 you will get, which is equal to R by R plus H. Cross multiply, my dear students. Capital R 8R plus 8H is equal to 10R. So you want the H value. 8H is equal to 10R minus 8R, which is equal to 8H is equal to 2R. H is equal to 2r by 8, which is equal to r by 4 you will get, my dear students. Means that at a height r by 4 from the surface of the earth, the acceleration due to gravity becomes 64% of that of on the surface of the earth. The same question can also be asked, at what height from the surface of the earth the acceleration due to gravity decreases by 36%. Decreasing by 36% means 36% come over here. But how much is existing? Out of 100, 36 is decreased. Remaining is 64%. Therefore, the same question, if acceleration due to gravity at a certain height decreases by 36% of that of on the surface of the earth, then what is the height of that place from the surface of the earth? If it is asked, in the same way you have to do, and you will get the same answers, my dear students. So here at Sri Balaji Educare Center, we explain each and every problem. We have in our material 2 levels, level 1 and level 2. For students purpose, level 1, level 2, and for teaching purpose, level 1, level 2 are there. We explain each and first we explain entire theory part. And after that we explain all the problems. And after that you will solve the problems from the student practice side. And if you have any doubt in that, those doubts also cleared by the respective faculty. So this is a small concept regarding the gravitation, my dear students. So hope that all of you are enjoyed this video. So let us meet in the next video, my dear students. Till then, bye bye.